Okay, folks, so we're going to talk variation today. I'm going to go through the first two pages of the variation, and there's a problem two to try. The answer key is on Teams. You literally just go on Teams, look at the answer key. It sets it all up for you. It's either direct or indirect variation. I'm going to go through these. I'm not going to go through all 15 or 20 examples, 15 or 13 examples. I'm going to go through some of them, and then you're going to try the rest on your own, and this says to try your own section. But again, the answer key is online. It's just a PDF at the very bottom of the page. All right, so if things vary directly, we're talking about the idea that as one goes up, the other goes up, and there's a constant of proportionality between them. We say y varies directly as x, and we talk about the idea that two variables, x and y, are in an express relationship where y equals k times x, or and k being your constant of proportionality. x1 is to y1 as x2 is to y2. So if we look at example number 1, it says the power p of gears varies directly with the radius r of the gear. Find the constant proportionality here. Well, what we're saying here is we're saying that you're going to be the power is going to be p, right? So it's p is to r. P is to r. So it's 300. That's a 0. That's a 0. And that's going to be 300 is to 5. So the answer here is 6. Okay? So your constant proportionality, your k value here for number 1 is 6. Number 2 says y varies directly as k squared. Now be careful. This capital W over k squared. Okay? If W is 75 and we have to now square the 5 because that's what the k value is, what's the W value, W2 in this case, right? You don't need the subscript when this is just 2 square. So what you got here is 75 over 25, and you have k is 2, and so that's going to be a 4, and this is W. So really what you have is 3 over 1. 3 over 1 is equal to something over 4. You cross multiply and you get that W here will be 12. So that's example number 2. All right, now in example number 3, it says 3/4 of an ounce of medication is required for a 120-pound adult. At that same rate, what would the dosage be for a 200-pound adult? Well, if it's 0.75 for a 120-pound adult, how much you're going to give someone who's 200 pounds? Clearly, it's going to be more than 0.75. Cross, you end up at 150 is going to equal 120 x divided off by the 120. Now the zeros of course cancel. 15 divided by, you're going to have at 1.25. That's a decimal point ounces of medication for that person. So and that makes sense. The person weighs more. They should be getting more medication. All right. So those are very directly. Now let's talk about very inversely. So inverse variation is a relationship where there were two variables which the product is a constant. Okay. So your product is a constant, meaning that x times y is going to equal k, where here originally it was y equals x times k. So it's y times x equals k. And also we're going to talk about the inverse variation of x1 is to x2. So x1 over x2 is y2 over y1. Example 4 says they vary inversely. So it's going to be x1 over x2, y2 over y1. Okay, so if when y is 39, x is 3, right? So in this situation, we're talking about you're going to have your x is 3, so 3, and that means this guy is 39. What happens when x is 11? I'm going to put a y there. Okay, and what we're going to do is you're going to cross multiply. Okay, you're going to cross multiply now, and what happens is you start cross multiplying here. You're going to get 3 times 39 is going to equal 11x. Okay, so 3 times 39. So you're going to have that your 3 times 39 is going to give me 117 equals 11. No, excuse me, that's not an x. That should be a y. I'm sorry, ladies and gentlemen. That should be a y. Y. So we divide by the 11 Divide by the 11. So my y value here is 117 over 11. Number 5, it says the time to prepare a field for planting is proportional to the number of workers. So if we have 5 workers taking them 24 days, how many workers will it take to get it done in 15 days? So I'm going to put an x there, right? And then when you multiply this out, these are going to be equal to each other. You solve for x, and what happens? You have 120 is going to equal 15x divided by 15. So you're going to need 8 workers, right? So he needs to hire three more workers. I think it says how many more does he need to hire. How many additional workers does he need to hire? 3 more he's got to hire. You need 8 total to get it done in 15 days. The only way you're getting it done in 15 days is if you have 8. He's got 5. He's got to hire a few more people. All right, so now let's take a look here at the last one we're going to talk about. The weight of a person varies inversely as it does when they're on the center of the Earth. Obviously, we're talking about a radius for the center of the Earth. That radius for the center of the Earth is going to be 4,000. That's given to us. How much does a person weigh when that person is now 2,000 miles above the center of the Earth? So you're going to have someone's a 180-pound person. That person is going to go, and this is the radius. This is the person varies as the distance squared. So what we're going to have is a 180-pound person is to, I don't know how many pound person, is going to be 6,000, because that's 6,000 square over 4,000 square. Why? Because if you're 4,000 feet from the center of the Earth just beyond the crust, I need to know how much it's going to be when there's 2,000 higher feet in the air. You cross multiply, right? So a person who's 180 pounds at ground level now needs to make sure that they're 2,000 feet above that. And at 2,000 feet above that, what happens is now you have to square that number. So when you cross multiply and divide, you're going to end up with these giant numbers. This is all straight calculator work. So what happens is you end up with your x2 coming out to be 80 pounds. Very simply in your calculator, you can do 180 times 4,000 squared is going to give you, and then divide that by 6,000 squared, and the person would weigh 80 pounds. Well, that makes sense, right? Because we know as we go further away from the Earth, we lose the gravitational pull, and all of a sudden we start weighing less and less and less. All right? So now what you're looking at here, for the other ones, they're all set up for you. This is Hooke's law, and that's simply 20 over 3 equals x over 8. Number 8 is the time required to do a job varies inversely in the number of people working. This should come out to be hours and minutes, so it's 5 times 7. So it's 5 times 7 is going to equal 12 times x, and the value here is going to be 2 hours and 55 minutes because you're going to get 35 divided by 12. Like I said, every single one of these is in an answer key attached to Teams. It literally is a PDF you can go look at. All right, you need to try these on your own. You need to make sure if it's direct variation, you set up directly. If it's inverse variation, you set up inversely. And the idea is that this is not the most earth-shattering of lessons, but you need to know how to do it, because if you set them up incorrectly, you will continue to get them wrong if you're doing inverse when it's direct or direct when it's inverse. And it tells you, it flat out tells you what's happening in the problem. If you look at it, obviously if it takes 2 painters 9 hours to scrape a house, how long would 3 painters take? Well, it better not take longer. It better not all of a sudden take longer to get stuff done. In this case, it'll take 6 hours. But if you have 2 people working and then they have 3 people working, 3 people, again, all actually working, should do more. All right, ladies and gentlemen, like I said, I wanted to keep this short. You need to work on these on your own and check your answers against the key. Okay, and then what we're going to get into our series and sequence stuff in the next couple days, and you need to make sure that the take-home notes you're getting on that you go through and actually watch the video and actually do what you're being asked to do, and make sure that you're ready to go. So as soon as I'm back in that room, that we're not dragging, going, oh, Mr. J, I don't know. No, you need to make sure